Hello, and welcome to Introduction to Computational Thinking. As you may know, the class Computational Thinking is a pretty new one because now that computers are so inexpensive and so everywhere, it's important that more people have some understanding of how to use them and how, eventually, even to program them. And it really turns out that they're not as bad as a lot of people think, but we're going to let you be the judge of that as this course goes on. So to begin with, one thing that's important to remember is we think, we humans. Computers only operate. They don't think at all. And that's why there's the old joke that if you tell a robot to put on its shoes and socks, that's what you're going to get. You're going to get the shoes put on and the socks put over because they will do exactly what you tell them. And they can't think out of that box. We, the humans, have to learn that robots and other computing devices do things in a very sequential manner. And therefore, we must tell the robot, put on the socks, then your shoes. So, one of the things that will help us to know about computers is to begin to develop some ideas of what they do, what they can do. And one of the things we know computers can do all kinds of arithmetic and multiplication. So that's not news. But here's something that you might not know you can do much better than a computer, which is you can identify letters in a whole bunch of letters very quickly. For example, if I type just some random thing, and I ask you, is there a capital T in that string? And you'll be able to answer me very quickly that there is. But if I give that same string, or what I should say is a text message to a computer, what the computer will do is say, okay, here's the first thing. Is that the first thing, which happens to be a J, is that equal to a capital T? No? Okay. No, I'm going to go to the second thing. The second thing is a K. Is that equal to a capital T? No? All right, then I'm going to go to the third thing. And it will do this no matter what length of string I give it. And the only good thing is that it could stop right away. If I asked it, programmed it to stop right away, it would. But basically, it has to go through the whole string. And in the very worst case, if the T is there as the very last letter, it has to go through all of them. So this is something humans are much better at because we do it holistically. But the computer is much faster than we are, and so the computer might do it more quickly. So there are a lot of tasks which are really, for example, boring to humans, and computers can do them efficiently and quickly and save us from having to do them ourselves. For example, if I gave you 100 books to read and said, how many times does the word apple appear? Well, that doesn't sound very interesting. It isn't very interesting, and you can solve that problem. You can read all those books and you can look for the word apple. And most humans will actually get that wrong, simply because it is such a boring task that ultimately they will zone out. Computers, on the other hand, never zone out. They will happily go through all 100 books and they will count every single occurrence. So that's one reason we want to learn about them, is because we want to hand off some of the work that we don't really enjoy doing, and which, ironically, because we think and we get bored, and computers never get bored, they're actually better at than us. Okay, so with any machine, what we need before we begin to understand it is some kind of model. And if we look over here to the other side, you'll see a whole bunch of things that are pictures of a toaster. And this is a machine that we mostly have all used several times in our lives. And what is the model of a toaster? The minimal, let's say, model. What do we need to know about it? Well, we need to know there's a place to put bread. We need to know there's an on-off switch. There's a plug so that we can plug it into the wall for power. We might want to know that there is a bell as a signal, done. And there's a darkness setter. Now, knowing that, those 5 things, you can look at all kinds of pictures of machines that are about the size of a toaster, and you can figure out pretty fast whether it's a toaster or not by checking to see if these things are there. So that's your model of a toaster. Now, if the toaster had a problem, it wasn't working, you would want to take that toaster into somebody, maybe a repair person, and that repair person would understand these 5 things, and that repair person would know this model, but they would also have a bigger model because they would understand inside this box that's a toaster how the heat is generated from the electric. That's something I don't understand. But they would understand that, so they would have a chance to repair it, for example. So their model is different than our model. And so there's a user model, and there's a repairman model, and there's probably the person who put it together's model. There's probably a lot of different models. But when we learn a model for computing, we don't have to know the equivalent of a repairman model, at least not right away, or at least not unless our interests guide us to knowing such knowledge. So for now, the important thing to understand is that we need to develop some model about how a computer works, because then we can start thinking about how to interact with it, or in other words, program it, how to think the way a computer is operating. And that's it for this lesson.